Hello and welcome back to 13.4 Compound Interest. We're going to start with Explain 1. On here it says Modeling Interest Compounded Annually. So here we're given a word problem. A person invests about $3,500 in an account that earns about 3% annual interest. Find the value of the investment when it reaches $10,000. So the whole point about investment is that we'll put money in and then over time it'll grow without doing anything else. So the first thing we're going to do is identify our principal or initial value, which is 3,500. Then we'll do our rate. And our rate is 3%, but we do want to change that to a decimal. And the way we do that is by dividing by 100. So go ahead and calculate that out. And you should have gotten 0.03. We are then going to use our formula for calculating compound annual interest, which would be about 3,500 for our principal, 1 plus 0.03 t, and then go ahead and simplify this out a little bit further. Take some time to calculate that out. That should be about 1.03 to the t power, where t stands for the number of years. So we're going to use our graphing calculator, our favorite, Desmos, to kind of figure out at what point this investment that this person invested of $3,500 reaches the goal of $10,000. So let's take a moment to go ahead and open up your favorite, Desmos.com, and we are going to be using the graphing portion of this application. Alright, and welcome back. Today we're going to be graphing. So let's go ahead and open up Desmos. We're going to press the Start Graphing key, and we're going to type in our equation y equals 3,500 parentheses 1.03 parentheses exponent key. So again, there's that keypad that we can use to the x power, and then y equals 10,000 because that's the desired amount. Now as you can see, there's nothing on my graph, right? So let's go ahead and kind of zoom out a little, just like it says here. We're going to zoom out. We're going to continue to zoom out until, oh, there's the graph. And you'll see at some point there's the line. So it looks like this line and this amount kind of meet at a certain point. So what we're going to do is I'm going to use my zoom in function by putting my fingers on the x-axis and just kind of tugging on that and zooming out a little. Zooming out a little more, and you can see that this exponential function and 10,000 meet at about 35 years. So if this person doesn't mind waiting 35.5 years, they'll have $10,000. The moral of the story is, guys, make sure you're investing starting as soon as you can earn money, because it does take some time to have money grow. So let's go ahead and record that on our paper here. So the value of the function is at about $10,000 after 35.5 years. So the investment will be about $10,000 at about 35.5 years. As long as you're willing to wait, right? Let's go on to part B. Again, modeling interest compounded annually. So here, let's say the person wants to invest about $200, which is a lot less, but their interest rate's a lot more. So again, let's identify our P, which is about $200, and our interest, which is our rate, is at 6.25. So let's go ahead and change 6.25% to a decimal by dividing by 100. So take some time to calculate that out. And that would be about 0.0625. Let's then plug in our principal and our rate. +1, of course. Now, the reason why it's a plus symbol is because it is growing. If our money was losing money, it would be a subtraction symbol, which is just a sad notion, so we're not going to talk about money being lost right now, but money being grown. So principal is about $200. 1 plus 0.0625. And in fact, we can actually simplify that out. So take some time to do that right now, because we're going to graph that function of $200 times 1.0625 to the t power. And they want to know at what point the investment will grow to about $5,000. So at what point or how many years it'll take this investment using this equation would reach $5,000. So again, let's take some time to use Desmos. Try that out. So I opened up Desmos. This is from my last problem that I did. So I'll go ahead and type in now $200 times 1.0625, close the parentheses, to the x power. Remember, we can get to the x power by pressing this key and then x. And in this case, we want this to be actually $5,000. All right, and you can see, oh, our graph actually crosses at about, wow, great things come to those who wait, because that looks like about 53 years. If a person's willing to wait 53 years, that will grow to $5,000. I don't know about you, but that's a long time to wait. So let's go ahead and record that down. So that would be about 53 years for that investment to grow about $5,000. Now, I know that that sounds depressing, you know. Oh, I only invested about $200. So it's important to invest a lot of money, so when that time does actually come, you can see that it actually does grow. So save, save, save is the moral of this mathematical story. But for now, go ahead and stop right here and do the problem in your packet, and we'll go back to the next explain after this one.